Waves. How can water waves show wave behaviour and relate the principles of reflection and absorption? Ripples in the water. Water waves are transverse waves, with the surface of the water moving up and down. The waves form crests and troughs where the level is higher or lower than the water when it is still. So the crests are the tops of the waves, troughs are the bottom, wavelength is trough to trough, and the amplitude is half the height of the wave. So the wave has a direction, and we can see where it is coming from and where it is going to. Therefore, you can measure its speed. So the way in which you measure speed is you measure the distance and then divide that by the time it takes to cover that distance. We can also picture the shape of the waves as they look from the side, and this makes it obvious that they are transverse. We can see how long and how high each wave is. The amplitude is measured from the level of the water when it's still, so this would be the level of the water when it's still, so the amplitude is the height from when it is still. You can either measure it to the peak or to the trough. Reflection. So water waves can be reflected by hard surfaces just like sound waves can, and their behaviour can be seen using a water tank. And if some of the water ripples are generated in the tank, blocking their path with a solid object shows the wave is reflected. And the wave is reflected by the barrier, and the angle it is reflect is the same as the angle it arrives. So the angle of incidence is the same as the angle of reflection. So you can see that here, that the angle that it arrives is the same as the angle that it leaves. Superposition. So when two pebbles are thrown into a pond, the ripples produced will meet. And you can see what happens when they meet. When two waves from different starting points meet, they can either combine to make a bigger wave, or they cancel each other out so they don't make a wave at all. And that is called superposition. So if the crests correspond, the waves add together to make a bigger wave. So if their crests are at the same point, so the troughs are at the same point, then what they do is they add together to make a much larger wave. However, if the crest of one wave meets the trough of another, that means that they actually just cancel each other out and you end up with no wave. So this is called superposition. So if they match, the crests are at the same place, then they will add together to make a bigger wave. But if the crest and the trough meet, then that means they will just cancel each other out, and this is known as superposition. So you can see that here, same point, they get taller, but if the troughs and the crests meet, then they cancel each other out and you end up with no waves there. But then when they're let's just wait. So when the trough and crest meet, there's no wave. When the crests are at the same point, the wave's bigger. That is superposition.